divide by 104, right? And then you have your NMZ, which is equal to 17.936 times 10 to the power 3, and then you divide by 65.694 times 10 to the power minus 6. Okay, then you multiply by y. Okay, so your y value over here will be negative. So minus 1.359 power 6 times 104 times 65.694 power minus 6 divided by 200 divided by 17.936 power 3. So it's equal to minus 2.588 times 10 to the power minus 3 meters. Okay. Now this is only if you can remember equation number 1. If you don't remember question number 1, is also fine. You can use a simpler method. Okay, so I'm going to show you a method that if let's say you forget equation number 1, okay, how to do by using a simpler method. Okay, so now I'm going to sketch. Okay, I'm going to sketch our stresses distribution for material number.
What about,
yes.
sorry, what about dividing by A1 over E2 plus A2?
Yeah, that is the minus 1.359 times 10 to the power 6.
Oh, that's the value. Okay.
Okay. So now let me show you a simpler method if you don't know, or if you don't know how to, or you cannot remember equation number 1. Okay, and it's just using high school math. Okay, so it's straightforward. Okay. So I'm going to sketch our stress distribution for material number 2. Okay, so I'm going to write down go on. Let's delete. So we are going to look at the normal stress distribution for material 2. Okay, we're going to look at the normal stress distribution for material number 2. And so we are going to have our x-axis. So this is our stress x. So we're going to have minus 100, 80, 60, 40, 20, 0, 20, 40, 60. Okay. And then we have our axis. So this is our y. So this will be 0.05, 0.10, 0.15, and then minus 0.05, minus 0.10, 0.15, minus 0.20. Okay. So if we were to look at our values, right? So we have 60.797 times 10 to the power 6, and this will be at 113.207. Okay, so I'm just going to sketch it. So we know that we are going to have 60.798. Okay, and then our y is 0.113, so 0.113. So this is 0.125, 0.113 is somewhere around here. Okay, so this is our point. So this is, we calculated this earlier, 60.797. And then this is 0.113. Okay. And the other one is at 91.465. And then 0.3 minus 123, 0.3 minus 0.123207 is equal to 0.176. Okay. So 0.176, 175, 176, and then we have minus 91, so is somewhere around here. Okay. So this is equal to minus 91.465 and then minus 0.176. Okay. So this is times 10 to the power 6. And over here, this is in meters. So when I sketch this out, you can see there is a shift of the neutral axis from the centroid, right? So this is the new position of our centroid. Oh, sorry, neutral axis. So you can see that this is a shift. Okay. So this green line is our neutral axis. So we just need to form the equation of the line. Okay, real straightforward. So we are going to find the gradient. Which is equal to the change in y over the change in x. So the change in y, I'm gonna take the change in y is equal to 0.3, and then the change in x is 60.797 minus by 91 or minus 91.465. So this will be equal to 60.797 plus 191.465. 0.3 divided by, so it's equal to 1.97, 1.9703 times 10 to the power minus 3. Let me do it again. So 0.3 divided by 60.797 plus 91.465. Yep. Okay. So now when we know this, so if we were to create a function, so y is equal to 1.9703 times 10 to the power minus 3 by the stress value plus by the I call this C. Okay, so C over here is the y-intercept. So to find the y-intercept, we just need to substitute. Okay, so I'm going to call this A. Substitute the stress is equal to 60.797. Y is equal to 0.113 into equation A, right? So 0.113, this is equal to 1.9703 times 10 to the power minus 3 multiplied by 60.797 plus by C. So C is equal to 0.113 minus by 0.113 978 or 979. Okay, so this is equal to 0.113 minus 0.11979 is equal to 1.9703 power minus 3 times by 60.797 119.78. So 0.113 minus 0.11979. I get a, hold on, let me check my calculation. 113. Did I enter something wrongly? 60.797 plus 191.465. 0.3 divided by this. 0.97, 1.9703. I'm getting a very small value, which is wrong. Wait. 0.3 is the y-intercept. 60.797. 0.3 divided by. So it's 1.9703. This is correct. So y equal to minus 1 is positive 9703 times 10 to the power minus 3 plus by c. 60.797 y is equal to 0.113. This should be more straightforward, but I'm not getting the right answer. Hold on. And I'm doing everything in. So this is in meters. Wait, this is in meters. This is also in meters. It's fine. In meters. So y 1.9703 power minus 3 times by 60.797 0.11978.113 minus 0.11979. 0.113 minus 0.11979. I get 6 point, hold on. Let me change everything into meters, okay? But that should not make a difference. Hold on. 60 point, I did plus, so 0.3. 1.9703 times 10 to the power minus 3 is correct. So we're going to find the y-intercept equation is correct. I'm using 60.797, correct. 113. And my 113 is in meters, 113.207. Maybe I round off too much. 0. The answer is 2.588. I'm getting, hold on. I do apologize for this, okay. Minus by 1.0. 2.613. Okay, let me do everything in meters somehow. Somehow, I think I have to do everything in meters. Then I will get the right answer. Hold on. I will not cancel it. Let me do everything in meters, okay? So, or in Pascal. So gradient is equal to delta y over delta x. And this is in meters. And this is 60.797 times 10 to the power 6 minus minus 91.465 times 10 to the power 6. Okay. So this will be equal to